7 hours usually, because it's like low tide.
Okay.
3 hours.
Well, anyways, let's have a look at it now. So, Dorian, would you be so kind as to give me the info? What was the story? You had
There's a dock,
there's a dock, and the low tide
1 meter.
is 1 meter.
High tide is 11 meters.
Yeah, this is a super tide.
Yeah, and then the boat is at the bottom right now.
Yeah, and what depth does it need?
5 meters.
It needs 5 meters of depth. So it needs to get to the 5 meter mark.
Yes.
So if you look at this, imagine you have a little dot here,
Mm.
okay? What way will this move? It'll move simple harmonic motion. It'll go up, down. Yeah? The origin would be here, correct?
Yeah.
And the amplitude would be what?
5.
Be 5. Okay? And is it a cos or a sine? Is it starting on the inside or the outside?
Outside. So
Outside.
cos.
Positive here and negative here.
Mm.
Now, we need to have a depth of 5 meters. So we need for it to get to what value here?
1. No, we mean from.
Yeah, so that would be 1, isn't it?
Yes.
What height is this? This is 6,
Yes.
is it? So this is 5.
Wait, what?
So, and this is 5.
Yeah.
Yeah, this is 1. Yeah, it's 1. So we want the x to be 1.
Yeah.
So we have the formula x equals a cos omega t. So you have 1 equals 5 cos 2 pi t over t, which is 6 hours. No, t is not 6 hours, sorry. It's 12 hours. Because I said it's 6 hours to go from here to here, didn't I? So it's 12 hours, yeah. It's a full cycle. Now, for goodness, make sure you're in radian mode too. Is that it? Is that the secret, Dorian? So let me see. Cos inverse 0.2 times 6 times 3600 times cos all over pi. What's that?
$9,415.
9415. Can you divide that by 3600?
2.61.
Okay, can you take the 0.64 and multiply that by 60? 0.64 times 60?
156.
No, 0.64 times 60 has to be less than 60. Just the 0.64. 0.64 times 60, what you get? About 37?
38. Sorry, just 2.62, I think, because there's 9.42.
Yeah.
Yeah.
2:38 p.m. We said the story begins at noon.
Oh, okay.
So at 2:38 the boat can leave, or really any time shortly thereafter because the tide is rising.
That's the earliest it can.
That's the earliest it can leave. And obviously it can wait too long, so it has a window.
We made all rockets.
Yeah. How long of a window does it have? It'll take 12 hours to get back down to this point, so 12-hour window. Although boats don't usually leave.
Wouldn't it be the time from the top to the same point?
Yeah, 12. It's a 12-hour cycle. So no matter what point you're at, it'll be 12 hours to get to the back to that point, won't it? Or no, 6 hours.
Yeah, it would
Up
be
down 6 hours. Okay. But you don't usually want to be leaving as the tide is falling. I guess that could cause problems if you get delayed. Okay. So what did you do wrong, Dorian?
Written.
Uh-huh. Did anyone get this answer? Nope. Gina? Nope. Lynn? Did you get any answer? Gina, did you get any answer? Okay. Simple harmonic motion hard? Shall we do another? I think what I'd like to do now that I've done, 3 section B examples, I would like to, is what I do with the science students in maths. So I give them a question and I give them a time limit and then we go through the answer. Because you need to practice being able to do these questions in like 15 minutes. A long question 15 minutes, a short question like 5 minutes, I would hope your short questions are okay because you've been doing short questions for the whole year.
Yeah.
So we need to be looking at the long questions, the hard ones like this. So let's open up Moodle and find one. Yeah? Yeah.
I just don't know why it's that thing.
Ah, yx is 1. Yeah.
I know it's 6 minus 5, but I don't know why that is x.
Ah, so what I'm doing is I'm picturing it like
Displacement is
yeah, like
from the equilibrium.
from here. So it starts here and it goes up, down, up, down. So if I just turn this, oops, too far. With the simple harmonic motion, you measure from the equilibrium, which is the middle. So that's the A. So that's x, x. Now here's the x negative. So like this is x, the distance from the equilibrium. Tell me, if you don't think that's x, what do you think x should be? Oh, okay, just not sure. So for simple harmonic motion, the x is always from the equilibrium, from the center to the right. Yeah. Now there is no right here, but if you turn it on its side, whoops, this way, you can have here right, left. And you remember that if you start from the right, it's a cos. But if you start from the middle and go to the right, yeah, like this. Whereas here you start from the right and go left. This one here is the sine. And do you remember the way I said you can remember? Start from the outside, use cos, O, outside. Start from the inside, use sine, I. Inside. Yeah?
So it starts from
The middle. Yeah, from here. And you go to the right. And then left, and then right. Here, start from the outside, you start on the right, go all the way left and all the way right. All the way left and all the way right.
yeah, but we used cosine.
Yeah,
So,
because we started in the middle.
We used
No, the tide starts here. It starts on the outside and then,
Like one
The-
is the distance from the equilibrium.
yeah. But it doesn't matter if you start on the inside or the outside, the x is always from the center. Yeah. But this problem, when did we say it was now? Now it was noon, and we're starting at low tide, which is the outside. And it's going like this. So starts here.
Yeah.
And we have to wait for the time until it gets to here. And this is the x.
So regardless if you start on the outside, the x displacement
Always from the
is
center.
always from-
Always from the center. Inside, outside doesn't matter. X is from the center. Yeah. Good. Okay. This is good revision. Can I close this? Yeah. Will we open up some exams now? Let's see.